The future of work, and indeed, much of our daily lives, is increasingly shaped by artificial intelligence. Reports from sources like the World Economic Forum project that AI could create 97 million new jobs by 2025, but also displace 85 million. The narrative often suggests AI is only for an elite few, a perception that can deter many. Yet, the reality, as evidenced by accessible learning platforms, indicates a growing demand for individuals with even foundational AI understanding. This isn't just about becoming an AI engineer, it's about understanding a core technology shaping the next decade. Our objective is to demystify this path, making AI learning accessible and actionable for complete beginners. Skeptical that you, with no prior experience, can truly grasp artificial intelligence? That's a valid concern, often fueled by the complex headlines. However, our investigation into effective learning strategies reveals a clear, actionable path. We will outline 5 critical steps: first, mastering the foundational skills; second, grasping core AI concepts; third, adopting practical tools and libraries; fourth, engaging in hands-on projects; and finally, specializing and committing to continuous learning. This structured approach, supported by educational researchers, demonstrably overcomes initial skepticism by building confidence incrementally. The initial hurdle for many, as observed by numerous online educators, is often the perceived need for advanced mathematics. However, a robust AI journey begins not with calculus mastery, but with practical proficiency in Python programming, fundamental linear algebra, basic calculus, and core statistics concepts. These aren't just academic exercises, they are the bedrock upon which all AI models are built. For instance, understanding a regression line in statistics directly translates to how a simple machine learning model predicts outcomes. Skipping these foundations is a common mistake, leading to a superficial understanding and significant roadblocks later on. Industry experts, like Dr. Andrew Ng of Coursera, consistently emphasize their importance. For aspiring AI learners, Python stands out as the lingua franca. Data from developer surveys consistently places Python as a top choice for AI and machine learning due to its readability, extensive libraries, and vast community support. A simple Python script, for example, can manipulate data, a core requirement for feeding information into AI models. This versatility minimizes the friction often associated with learning programming. Our analysis of beginner success rates suggests that learners who focus on practical Python applications early on, such as data manipulation with pandas, achieve a faster grasp of AI principles than those who delay. The consensus among practitioners is clear: start with Python. One of the most frequent errors observed in our survey of AI learning pathways is the temptation to dive directly into advanced topics like neural networks without a solid grounding in the basics. This is akin to trying to build a skyscraper without laying a proper foundation. Learners often encounter impenetrable code or concepts, leading to frustration and abandonment. For instance, understanding why a gradient descent algorithm works requires a basic grasp of calculus. Without it, the process becomes a black box. To avoid this, dedicate specific time, perhaps 3 to 4 weeks, to Python fundamentals and the core math and stats. This investment pays dividends, as cited by numerous AI mentors. Once the foundations are laid, the next step involves understanding the core conceptual frameworks of AI. This includes machine learning, ML, deep learning, DL, natural language processing, NLP, and computer vision, CV. Think of it like learning about different types of engines. They all power vehicles, but operate differently. For example, a basic ML algorithm might classify emails as spam or not spam based on keywords, while a DL model could identify complex patterns in images to detect cancerous cells. The critical takeaway here, according to AI academic professor Fei-Fei Li, is not memorization, but developing an intuitive understanding of what these techniques achieve and when to apply them. This intuitive grasp is often overlooked. To illustrate, consider 2 fundamental types of machine learning: supervised and unsupervised learning. In supervised learning, it's like teaching a child to recognize cats and dogs by showing them pictures and explicitly labeling each one. The model learns from this labeled data.
In contrast, unsupervised learning is like giving the child a pile of mixed animals and asking them to sort them into groups without any labels.
The child, or model, identifies inherent patterns to create clusters. This distinction is crucial for selecting the right approach, as highlighted by machine learning mastery resources. Understanding this conceptual difference helps avoid the mistake of applying the wrong algorithm to a problem, a common misstep for newcomers. A significant pitfall, according to feedback from our learning cohort, is getting bogged down in the intricate mathematical proofs and theoretical minutiae of every algorithm. While academic rigor has its place, for a beginner, this can lead to analysis paralysis and burnout. The goal initially is to understand the what and why, not necessarily the how at the deepest mathematical level. For example, grasp that a convolutional neural network, CNN, is excellent for image recognition without needing to derive its backpropagation algorithm on day one. Prioritize practical application over exhaustive theoretical depth, a strategy advocated by practitioners in towards data science publications. Build intuition, then dive deeper when necessary. With conceptual understanding in hand, the next critical phase involves equipping yourself with the practical tools of the trade. This primarily means mastering Python's powerful AI libraries, NumPy for numerical operations, Pandas for data manipulation, and scikit-learn for classic machine learning algorithms. Think of these as your indispensable toolkit. A carpenter doesn't build without a hammer and saw. For example, scikit-learn can implement a logistic regression model in just a few lines of code, abstracting away the complex mathematical implementations. Competence with these tools is a direct pathway to hands-on AI development, as demonstrated by the success stories shared in developer forums. Beyond traditional ML, the realm of deep learning requires specialized frameworks. TensorFlow and PyTorch dominate this landscape, offering powerful capabilities for building and training neural networks. While complex at first glance, these frameworks streamline the development process significantly. For instance, creating a convolutional neural network for image classification, which would be an immense undertaking from scratch, becomes manageable with PyTorch's modular components. A report by NVIDIA indicates that proficiency in these frameworks is increasingly a baseline requirement for roles in advanced AI development. While it's not necessary to learn both extensively, choosing one and gaining solid familiarity is highly recommended. The third common pitfall, frequently cited by those who struggle with AI, is getting stuck in tutorial hell. This phenomenon occurs when learners endlessly follow online tutorials without actively building anything on their own. While tutorials are excellent for initial guidance, passively replicating code does not foster genuine problem-solving skills. For example, simply running a pre-written Jupyter notebook on image classification provides little retention if you don't then adapt it to a new dataset or modify its parameters. To escape this trap, as advised by AI educator Suraj Raval, shift from copy-pasting to understanding and modifying, and eventually, building from scratch. Active engagement is paramount. The most effective way to solidify your AI understanding and overcome skepticism about your own abilities is through hands-on projects. This is where theoretical knowledge transforms into practical skill. Think of a chef learning to cook. They don't just read recipes, they cook. Data from platforms like Kaggle show that participation in real-world challenges dramatically accelerates learning. Start with simple projects, like predicting housing prices using linear regression, or classifying handwritten digits with a basic neural network. The key is to complete projects from data acquisition to model deployment, even if they are small scale. Each completed project is a tangible achievement and a stepping stone to more complex tasks. For beginners, selecting the right project is crucial. Our analysis suggests opting for well-defined problems with readily available datasets. Consider these examples: a spam email classifier using a basic naive Bayes algorithm, a sentiment analysis tool for movie reviews, or an image classifier that distinguishes between cats and dogs using a pre-trained model. Platforms like UCI Machine Learning Repository and Kaggle offer vast repositories of clean, structured data perfect for initial experiments. The primary objective is to gain end-to-end experience, facing and solving real problems, which builds both competence and confidence, according to interviews with entry-level AI developers.
The fourth common mistake is perfection paralysis, waiting until you know everything before starting a project. This often leads to indefinite procrastination. In AI, iteration is key.
Your first model will not be perfect, it will likely be far from it. The value lies in the process of building, testing, learning from errors, and refining. A study published in Educational Technology and Society indicates that iterative project-based learning significantly boosts self-efficacy compared to purely theoretical approaches.
Don't be afraid of messy code or suboptimal results. As veteran developers frequently state, done is better than perfect. Embrace imperfection, and you will learn faster.
Once you have a solid foundation and some project experience, the final step involves specializing and committing to continuous learning. The field of AI is vast, encompassing areas like natural language processing, computer vision, reinforcement learning, and AI ethics.
Trying to master all of them simultaneously is inefficient.
Instead, identify an area that genuinely interests you or aligns with career goals.
For instance, if you're fascinated by chatbots, focus on NLP. Data from job boards shows a clear demand for specialized AI skills. Continuous learning is non-negotiable. AI evolves at an unprecedented pace.
Subscribing to research papers, attending webinars, and joining communities are essential, as emphasized by AI Trends Report. Staying current in the rapidly evolving AI landscape demands specific strategies. Industry reports often highlight how algorithms and best practices can shift dramatically within a year. A common effective approach involves following key research labs like Google DeepMind or OpenAI, reading their latest papers, and engaging with AI communities on platforms such as Reddit or /Machine Learning. Furthermore, online courses that are regularly updated, like those offered by edX or Udacity, provide structured pathways to acquire new skills. The critical insight here, gleaned from successful AI professionals, is to allocate dedicated time each week, perhaps 2 to 3 hours, specifically for learning new developments rather than reacting only when a new technology emerges.
Finally, a frequently overlooked mistake is attempting to learn AI in complete isolation.
While self-study is fundamental, the collaborative nature of AI development means that engaging with a community is invaluable. Debates on forums, peer review of code, and shared problem-solving accelerate learning and provide crucial support. Data from open-source projects demonstrates that contributors who engage regularly with their peers tend to resolve issues faster and develop more robust solutions. For example, GitHub communities often provide feedback that refines a beginner's project. Actively seek out mentors, join online communities, and consider local meetups.
Your learning journey needn't be a solitary one.
Our investigation into how complete beginners can learn AI reveals a clear, structured, and eminently achievable path. The initial skepticism you might feel is valid, but it is also surmountable through methodical progress and active engagement. We've traced the journey from foundational skills in Python and statistics to the practical application of core AI concepts, armed with powerful libraries, culminating in hands-on projects and specialized continuous learning.
Each step, though distinct, builds upon the last, transforming abstract concepts into tangible capabilities. The data unequivocally supports that consistency and active participation are far more critical than innate genius. This isn't just about learning algorithms, it's about empowering yourself in an AI-driven world. The opportunity to understand and even contribute to the field of artificial intelligence is more accessible than ever before. As we've shown, success hinges not on innate genius, but on a structured approach, persistence, and a willingness to embrace the learning process. According to a recent survey of self-taught AI developers, over 70% reported that starting small projects early was the most impactful step in their journey. This evidence suggests the immediate action you can take. Begin with Python, explore a simple dataset, and start your first foundational project. The future of AI is being built by curious minds, and yours could be among them. The path is clear. The choice to begin is yours.